Hi there, and welcome to Season 3 of the Humans and AI podcast. In this podcast, we dive into the real-life stories of the top leaders and entrepreneurs within the artificial intelligence, high-performance computing and data center space. These people truly are at the top of their game. We've got honest and authentic conversations with our guests. We're going to chat about their career journeys, the highs and the lows, and even the lessons they've learned from their mistakes, and the victories they've celebrated along the way. It's all about sharing their experience and knowledge. We talk about the company they're currently in and how they see the future of the space. So if you're looking for practical advice from people who have walked the same path, or just a little inspiration, you're in the right place. We're going to be releasing new episodes on Thursday at 12, so make sure you stay tuned. Hey Matt, great to have you. How you doing?
Great. Thanks for having me. I am doing well. It is a sweltering hot day in Colorado today.
Oh, well, lucky for you. We're actually quite warm today. We've had huge rain for the last couple of days, but we had a heat wave last week and no one knew how to cope in the UK, so it was horrendous. But look, great to have you on board. For the benefit of the listeners and viewers, do you mind just doing a quick introduction as to who you are, your role, and a little bit about the business you work in?
Sure. Yeah. I'm Matt Butcher. I'm the CEO at Fermyon Technologies, where we're building the next wave of cloud computing. I personally have been in the cloud world for a long time. And in 2021, we started Fermyon with this vision of, kind of reinvigorating this serverless world, in particular, using this technology called WebAssembly.
Fantastic, thanks. Well, look, you said you've been in a long time, so let's go back to sort of close to the beginning. I mean, you were a developer in the 90s, but people often like to know about the background of the CEO of the business. So do you want us to take it back to where it all began, and we'll get quickly to here?
Yeah. I have probably one of the most unlikely beginnings in software engineering of anyone, because when I was in high school, my goal when I grew up was to be a philosopher. I don't think anybody ever says that when they're in high school. So that was kind of the path I was pursuing. And my my dad was not terribly keen on this idea because he wanted me to make a living wage and all of that. So he convinced me to get a job. In fact, he set up a job interview for me when I was maybe 16 or 17. And I went in for the job interview, and the interviewer asked me a couple of questions. She said, "Is it at a local Zero Escape demonstration garden, right, run by the city utility company?" And they asked me questions like, "So do you own steel-toed shoes?" And I'm like, "Well, it's the 90s. Of course I own steel-toed boots. Yeah, of course I do. Can you operate light machinery?" And I said, What do you mean by light machinery? And they're like, lawnmowers, weed whackers. And I'm like, yeah, sure, I can do that. And they said, great, you start in 2 weeks. And she ushered me out of the office, and I, called my dad, who came to pick me up because I didn't even have my driver's license at that point. And my dad said, "So how'd the interview go?" I said, I got the job. And he said, "Good, what are you doing?" And I said, "Oh, was I supposed to ask them that question?" And he's like, "Okay, well, tell me what they asked you." So I told him, and he said, "Well, probably you're going to be mowing the lawn." And I'm thinking, yeah, well, that's a good guess. So a couple weeks later, I showed up for my first day of work, wearing my flannel shirt, my baggy jeans, and my steel-toed boots. I mean, I was like trying to dress like Kurt Cobain. And I got walked into the front, and the woman at the front desk said, "Oh, hi, what can I help you with?" I said, "I'm Matt. I'm starting this is my first day at work." And she said, Great. So she looks at her pad of paper and says, "Okay, who hired you?" And I said, "Well, Connie hired me." And she said, "Well, Connie's out on vacation, but I can show you down to where you're going to work." So she leads me through the building, down into the basement, into a server room. It was like the first time I'd ever seen a server room outside of a movie. And she introduces me to a guy. "Bob, this is Matt. Matt, this is Bob. Matt's going to be working with you for the summer." I got a man in the front desk, and turns around and heads back upstairs. So I'm standing there next to Bob, and Bob says, "So you're an electrical engineering student at the local university?" And I said, "No, I'm a high school student." And he said, "Oh, well, I was going to have you rewire the phone system. Do you know anything about phone systems?" And I'm like, no, nothing at all. He said, "Well, what do you like to do?" And I said, "Well, I like to write, and I like to read." And so this is like 1995, right? Yeah. So he says, "Well, there's this thing called the World Wide Web that I think is going to be really big. So I want you to learn about it. By the way, I'm leaving in an hour to go on vacation for a couple of weeks." And he hands me a stack of books, sets me up with a login on a Unix workstation that I'd never used before, and walked out the door. So I spent a couple of weeks learning this, and so, built the world's worst HTML page, he came back from vacation, was happy enough with it that I kept going on this job. About a month and a half into the job, I got called upstairs to Connie's office, the woman who had hired me, and she said, close the door. So I closed the door, and she says, there seems to have been a mistake. We hired 2 people named Matt. One of them was an electrical engineering student who was going to rewire the phone system, and the other one was you, and you were going to mow the lawn. One of the 2 Matts didn't show up, and we assumed it was the high school student who was going to mow the lawn. It was, in fact, the other guy who just called us and said he had taken another job in Wyoming and wasn't going to come in. So as long as you don't tell anybody, neither will I. And I ended up working there for a few years, and that really kind of changed my passion from more academic pursuits into software. I did end up going on, incidentally, to get a degree in philosophy, but the pull of technology kept bringing me sort of back. And I've been started in really focused on content management systems. That sort of moved at one point at HP. I was doing content management systems there when they started HP Cloud. I got really excited about cloud. The first time I really understood it broke my brain, right? I went, all this time I had assumed we had to have one operating system for every piece of hardware. And now I'm finding out, we can not only do multiple copies of the operating system, but we could actually lease out operating system instances. And so I transferred kind of over to the cloud department, and from there, things just got going. And 15, 17 years later, I'm the CEO of Fermyon. So there you go. I should be mowing the lawns right now.
Well, we've all mowed the lawns. Some have, some haven't, but most of us. We had the same degree. That's what I did as well.
Okay.
And didn't necessarily use it too much in my professional life, but it's certainly gave me a good outlook on life nonetheless.
I mean, I find that the good thing about philosophy is you learn how to think about systems.
Yeah.
And whether you end up in technology, which is basically the most advanced form of system building that humanity has ever done, or you end up managing people, which is the most complex system you will ever have to run, I feel like philosophy is a pretty good table stakes kind of degree.
It was definitely, it was a fun degree to do. And whether you're listening to, reading about Descartes or Mills or Nietzsche, or whatever it is, they were all mad in their own right and had something to say.
Exactly.
So
it makes me feel better about myself, really.
Exactly that. So you did that. You kind of fell into something. Didn't cut the grass.
Right.
You've obviously been a developer. You've been a consultant over the years, supporting customers, whether it be software development or migrations or administration. And then you obviously what was the company before you went to Microsoft? You were acquired.
Deus was. So I had. I had this kind of weird period where I was going to startups and they were getting acquired and going to start, and so I went from HP Cloud to a small startup that then got acquired by Google. Didn't like Google very much at all. It just wasn't kind of my vibe, and so I left there and joined a small startup in Boulder called Deus. And we were trying to build an open source PaaS that would compete with, say, Heroku or Cloud Foundry, which wasn't quite a thing at that point, but that kind of so it's going to run on top of various kinds of clouds. And we were really into containers, which were brand new at that point. Docker had just sort of rebranded as Docker. About a year into that job, Kubernetes came around, and so we were really into that world. And Kubernetes was just such a cool technology. Again, it was one of those. I have these series of moments where I looked at something and it just sort of shifted my orientation about how I was thinking about technology. And Kubernetes was one of those moments when I thought, oh, this is just a completely different way of managing infrastructure. So we got really into Kubernetes at Deus and re-platformed all of our software into Kubernetes. Well, at about the same time, Brendan Burns, who had started Kubernetes at Google, got hired by Microsoft because Microsoft wanted to build the best Kubernetes offering on the planet. That was kind of their stated goal. And they gave Brendan a budget and said, build a team. And Brendan looked at our little team in Boulder, Colorado and said, you all would be a great team to build this service. So Microsoft acquired Deus and they broke us into 2 teams. One team went and built AKS, which is the Azure Kubernetes service, fastest growing service in Microsoft's cloud history. And my team became sort of an R&D team. And it was, I swear, it was the best job anybody can have at Microsoft. I led a team of about 12 people. At the time, Satya had just kind of taken the helm at Microsoft. I think he's a fantastic CEO. And one of the things that that was really important to him was repairing Microsoft's relationship with the open source world, because not long before, a previous CEO had said something to the effect of Linux is a virus and, open source developers were communists and all of that. And, people's feelings tend to get hurt when you insult them. And so,
just a little bit.
Right. Yeah. So Satya, who saw the value of this, really wanted to not just try and make amends with the open source world, but to become a really powerful player in the open source community, really playing by the community rules, respecting the contributions of lots and lots of developers. And so part of my mandate was to build a team that did that in the cloud native space, in the container ecosystem space. And the other part of my mandate was, hey, this whole container Kubernetes thing is fairly new. We don't yet know what we don't know, right? We don't know where the holes are, and we don't know how to fill them. So go out there, go to all the conferences, talk to all the customers, and build open source software that sort of fills the gaps. And, if we decide we want to turn some of that into product, you'll still be doing the open source part of it. We'll figure the rest. So it's really the best job ever. And so my team did all kinds of conferences. I would go visit customers. I would go visit other teams inside of Azure. And in one particular occasion, I went to a meeting with several different teams in Azure and got there about 15 minutes early. And so I'm sitting in the room alone. This other engineer walks in. We're sitting there. We've never met each other before. And I'm, being the extrovert I am, going, got to come up with a good intelligent question to ask this guy to break the ice. And so I just sort of blurted out, hey, what's the biggest problem that you have in Azure Compute? He was a core compute engineer. And I thought he was going to give me some esoteric answer like, well, when it comes to power management across this many units, we have to do this kind of, highly sophisticated thing. He looks at me and says, actually, it's really simple. He said, we rack servers as fast as we can. We get the hardware, we put it on the racks, install the OS, turn it on, and it's immediately claimed for production use. Mm-hmm. He said we can just barely keep up with the demand. But he said we'd also know that 80% of these systems are sitting, or that all these systems are sitting about 80% idle. And I said, they're claimed for production use and they're idle. Yeah, because of the ways technologies work, you tend to have these systems that are inserted into the production loop because the customer needs to make sure they can flex to that capacity, or because it's in a queue waiting to be used or something like that. And that was yet another one of those kind of eye-opening moments where I went, oh, that's a big problem, right? If you're expending that much capital just to get servers racked and they're sitting 80% idle, there's an efficiency problem there that should be solved. And that was really what got my team into trying to solve for this sort of next wave of cloud computing. And we looked at it and said, what are some of the problem spaces? How do we handle this? Turns out that serverless, as it's done today, is highly inefficient. And we said, okay, that's the thing we can tackle. Let's figure out how to do it. We started doing some experimentation. We ended up leaving Microsoft. And in order to have the kind of creative freedom we needed, we started Fermyon. So 10 engineers, we all left Microsoft on the same day, set off every red flag in the HR system, right? I got a call. You're not going to Amazon, are you? No. I'm going to go start a startup. Okay, well, that's fine then. And we've been kind of plowing ahead on that ever since.
That's exciting. So just so I've got this right, so layman terms, so when you've got these systems that are sitting there 80% idle, that is, they need to be up and running so they're accessible, they're available, but it's just the customers aren't necessarily using them, or it's just that the systems aren't actually,
Yeah, and I can give you an example from serverless, since that's the one that we've really targeted as sort of the one that was the most ready and prepared, the one that needed innovation the most. So serverless functions, we can think about AWS Lambda, Azure Functions, Google Cloud Functions, that kind of genre of compute. The idea when Amazon had a brilliant idea. They had extra VM space. They wanted to claim some of that and use and charge they wanted to charge people for some of that VM space while it wasn't presently allocated. So they had this idea that they could temporarily allocate some VM space to run just one request response loop. So customer would write a small chunk of code, deploy it out into Amazon Lambda, and then on a request, that instance would start up, handle that request, send a response, and shut down. So it's supposed to be for utility computing. And Amazon has said, frankly, in multiple cases, they never expected this to really take off. It was just a way to sort of utilize extra capacity, which was solving the exact problem that we have been talking about, right? But suddenly people wanted to use it and wanted to do lots and lots of compute with it and wanted to do very sophisticated things. So they built a system that worked kind of like this. They spin up a gigantic queue of empty virtual machines. So they pre-warm them because virtual machines take a long time to start up. If you had asked everybody to wait while you started a VM, drop the code on it, and then handled the request, people would never have used the service, right? It's seconds or minutes even to run that kind of thing. So what they do is they pre-warm a bunch of VMs and they keep a queue of thousands of VMs that are literally doing nothing. But they're in that queue so that when a request comes in, the first one can get popped off. You drop the code onto that machine, you run the code, you return the response, you tear the whole thing down, and you put another one on the back of the queue and shunt everything forward one, right? And the more popular the service got, then the more of this, these large empty queues of compute power you had running. And, even at that level of optimization, because the system is sort of just in time in a way, you're always dealing with fairly large chunks of latency. So it takes about 200 to 400 milliseconds to drop that code on there and start executing it. That's called cold starting. And so they not only could they not quite solve the efficiency problem over the long term, they were also introducing a latency problem that was preventing users from really extracting the value they wanted. And Azure Functions runs the same way. And so when we were looking at the way those kinds of systems ran, we were saying, there's the problem, right? They chose the wrong base technology because they need to start virtual machines, and virtual machines are really slow to start, and they need to wait until the last millisecond before dropping the workload on there and initializing it. They're always going to be stuck with a high latency, low performance, very costly and wasteful system to run. And that's what we could solve. So we started looking around for technologies that could solve it. We looked, of course, at containers first because we were doing a bunch of Kubernetes stuff. Ultimately, we couldn't find an existing cloud technology that worked. And one of the engineers on our team said, well, hear me out. What if? And he says, there's this technology in the web browser called WebAssembly, and it's basically designed to be a sandboxed environment to run inside of your browser. So the original use case for WebAssembly was, JavaScript is good at many, many things, but there are some things it is not good at. Things like high-performance numeric computing. And likewise, there's a lot of code out there in other languages that have been optimized in those languages. And it would be awfully nice if you could take some of that code, put it in the web browser, and let JavaScript just access it. Yep. So a good example of this is Figma. Figma, graphic design tool that runs in your browser. It does a lot of vector math. Not necessarily JavaScript's strong point. So they write the vector math code in C++, they compile it into WebAssembly, and they run it in the web browser, and then the JavaScript engine can call into this high-performance vector library. The way WebAssembly was designed, when you think about it, the web browser is actually our most trusted piece of software. Right? We use it every day. We visit strange sites on the internet that we have no idea who's running them and what their intentions are and stuff like that. And we just trust that the web browser is going to protect us from them. And if you ever talk to a browser engineer, right, somebody who writes the browsers for a living, they will tell you the most serious consideration is making sure that browser is secure and can prevent your browser from being used to attack other things on your system or other browser tabs or things like that. So WebAssembly was built with a super advanced security model. And we also know that people are really impatient when it comes to browsing the web, right? And they expect, pages to load very quickly. So on top of being very secure, it had to be very high performance. So this engineer on our team, Brian, is going, hear me out. It's really secure. It's high performance. We could just take this WebAssembly engine out of a browser, put it in the cloud, and build a serverless engine around it. And we're all kind of skeptical, but at the same time, it was like, it was, hey, let's break the internet. That sounds fun. Sure, let's try it out. And so we started doing some experimentation on it, and it turned out that it was far, far better fit than any of the other technologies we tried. So again, remember Lambdas, 200 to 400 millisecond cold start time. That's the time it takes from when the request comes in for the Lambda engine to spin up the code and start handling the user response. With WebAssembly, which is built for performance, we cut that from 400 milliseconds down to 1/2 of 1 millisecond because it was designed for really fast cold starts. And so, once we started seeing and the performance of this, and then we could solve the density problem where instead of having 80% idle CPU, we could really load up lots and lots of WebAssembly serverless functions inside of one runtime and get very efficient, very high performance, high utilization services. That's kind of the story of where we got. So we ended up building a couple of tools on that. But the core idea from Fermyon is, this next wave of cloud computing that's going to sit alongside virtual machines and containers is this kind of WebAssembly high performance, high efficiency environment.
So with the direction of the business, obviously, going back a little bit, you as an engineer, principal engineer, different roles, leading teams, you've been acquired by hyperscalers a few times, so you've watched that sort of transaction happen, and you've now kind of gone, I'm going to do this myself and build my own business, which is exciting as hell, and you've found where there's a gap in the market for a product and a service offering. Who's the sort of target customers now? Who's the audience that's going to be really interested in what Fermyon actually have to offer? Is it developers? Is it large enterprise? Where are you sort of targeting this?
Yeah, I think we have always viewed ourselves as an engineer, developer first kind of organization, right? And part of that is because we all are engineers, and we were solving a problem that we knew engineers had. But what we have always kind of envisioned was opening up the possibility for software developers to very quickly and easily build serverless functions. So, in addition to the kind of performance and latency and density problems that traditional serverless architectures have had, we also thought, we want to build like the best developer experience possible. When I first did the Amazon Lambda Hello World tutorial, it took me 40 minutes before I could test my first function. And I mean, when you think about it this way, right, the virtue of serverless functions is you write this little tiny snippet of code. Instead of writing a whole application, you write this little teeny snippet of code. It's just a function. It takes a request, it returns a response. And it was like, oh, this is great. I love writing these things. And then it's like 38 minutes to deploy this code. And I'm going, well, that really sort of, you feel kind of deflated when you're like, I wrote code in 5 minutes and now I spent 38 minutes waiting for it to deploy and configuring DNS and trying to route things to it. It was sort of a deflating moment, right? Yeah. And we said, well, we don't want developers to experience that. We want developers to feel productive right away. It was what got Ruby on Rails so popular. It was why WordPress gained so much traction. All the technologies you look at that developers really sort of flock to and that sort of instantly achieve success were ones that made their lives easier.
Yep.
And so we said, okay, we want to make lives easier. So for the entire first year Fermyon existed, we had one core user story. We had plenty of features we were working on, plenty of other things, but one core user story that everyone had to feed into. And that user story was, as a developer, I can go from blinking cursor to deployed application in 2 minutes or less. And we were saying we've got to hit that particular milestone. That's the only way that we're going to give developers that kind of, endorphin rush that they want. That's like, I built a thing and I can see it now and I'm going to build something bigger with this, right? That's the intuition you wanted them to have. So we really very much focused on developers. Now, over time, as you become a company that's actually supposed to sell stuff, you do have to be able to articulate this value prop to the people that you want to sell it to. And we learned that, making life easy for a developer was only part of the equation. You also had to make it, attractive for DevOps teams and platform engineers to install and run. But even today, as we've really worked to understand the broader audience and everything, we would still say, at heart, this is a developer-oriented tool.
So you've got a developer-oriented tool, and that makes sense because obviously, like you say, the business is run and founded by engineers.
Yeah.
You are a slightly different engineer in terms of your DNA, in the sense that you're out there, you're happy to chat, and you can probably we don't know each other very well, but you can clearly go out and sell. How do you actually get this business from where it was 2 years ago to where it is today, commercializing it? Are you out there speaking to all the customers? How do you run the business now?
So we started the company in 2021, which had some huge advantages. First of all, we didn't have to start with an office and bring people physically into the same location. We're like sort of tail end of COVID, and everybody was used to working from home. But I think one of the biggest mistakes we made was in the assumption that everything that had happened was sort of the new normal. And I'll give you a very concrete example of that. We assumed during COVID, when we're building a developer-oriented tool, during COVID, many organizations really let their developers have far more purchasing power than they had in the past, right? Yeah. And so there was one thing that we observed, one trend we observed from about early 2020 on into actually the first few months of 2022, was that developers were purchasing software as a service to do kind of what they wanted to do, right? So you saw a huge boom in what's called product-led growth, right? Where you put out the product for free. Developers in particular were who we were targeting. They'd sign up for free. They'd get this free account. They'd use it. They'd like it. They'd get a couple other developers from their team to use it. Then they'd upgrade to the team plan. And then more developers would use it, and they'd upgrade to the enterprise plan. And we looked at that and went, this is the wave of the future. This is how it's going to work. And this is great for us because we love developers and we are developers. And so our first real foray into the market was to build Fermyon Cloud, which was a developer-oriented, hosted serverless function platform that really had the software engineering process in mind from the perspective of the individual developer. Mm-hmm. And we had a very generous free tier offering, like nearly instantly went from 0 users to about 3,000 users in like a couple of months. For a brand new technology, like based on WebAssembly, which was groundbreaking, we were like, yes, we're winning, right? Let's introduce the enterprise tier. And we introduced the enterprise tier and sat there watching the screen, and nobody converted their free accounts to paid accounts. And we're like, what did we do wrong? And that was when we started looking at things and realizing that the economics, this is like early 2022, right? End of first quarter 2022. The economics had subtly shifted and we hadn't noticed. Mm-hmm. We started reaching out and doing a bunch of developer interviews. Our product team led a whole bunch of interviews with, many of the subset of that first 3,000 users of people outside that were not our users, trying to get some control data and stuff like that. And what we learned was that developers had sort of lost their individual budgets, that everything was being centralized again because corporations didn't necessarily like the idea that every developer was spinning up their own services and things were getting decentralized. And particularly and I think it's right that this happened, but as, legislation started to say, hey, you got to pay more attention to customer privacy, spreading out these systems all over the place and having individual developers responsible for managing the privacy of these things and the security of these things was not the best use of an enterprise's resources. So you saw this sort of reversion back to a centralized, more controlled model in which the platform engineering and DevOps teams really ran things, as I think they should have. And we went, oh, we don't have a product for them. So we really sort of shifted from there and reoriented from building a product for developers to saying, okay, let's think about the problem we're trying to solve. We want to make it easy for developers to build serverless functions. Check, right? Did that. Now we need to make it easy for the teams that service the platform engineering, DevOps, to install a runtime that these developers can then deploy to. And so from there, we sort of pivoted over and built Fermyon Platform for Kubernetes, which was basically a serverless toolkit that you could drop inside of your Kubernetes cluster and would run serverless workloads that were built with WebAssembly. So we really kind of pivoted as far as the audience went and the target there. And that's when we started to find, our first inklings of commercial success, because then we knew who we were selling to. And it wasn't the developer. It was, the directors of engineering teams, the directors of platform teams and stuff like that. And we knew how to talk to them, right? We can improve your developers' efficiency. We can, squeeze more out of your existing hardware or cloud investment, which means, you got getting more for your money. You can save this amount of money, and things started to take off from there.
So how did you get the audience with them? Because obviously before it was about just getting developers free accounts and then hoping that would naturally organically grow into paid. Obviously now you're going, right, I need to speak to a director of engineering or a CTO, and I need to sell a service. So how did you create that plan?
That was actually the hardest transition, right? In one way, engineering had a fairly easy transition. They were going from focusing on, building the developer tool to then saying, okay, well, we'll extract the runtime. We can do this. We're engineers. We know how to do this. This is what we're passionate about.
So
but for me and for the but for me and for the marketing and product functions in the company, it was a really hard adjustment because first of all, we had to get honest and say, okay, this PLG motion is failing. Right, all the way we've invested in our platform over the last year and a half has been good for raising developer awareness, and we've built fantastic relationships. But as far as enabling us to pay the paychecks of our employees, we're not making progress. We changed motions a couple of times there. We went very much into the enterprise sales motion. That was hard because it was not natural for me, for example, to try and reframe everything in CIO talk and go to CIOs. But then we realized, well, wait, we've been in the Kubernetes space forever. Like of the engineering team, I think eight or nine of the core engineers and probably over half of the engineers we have today have been core contributors to Kubernetes and the Kubernetes ecosystem and Docker and things like that. And we went, well, that's where all these platform engineering teams are hanging out, and the decision makers for that are all going to the same places. KubeCon, Open Source Summit, we started listing off these DockerCon, all these conferences, and went, so we just need to change our messaging and really start to approach them there. And so that's what we did. We would go to like Civo Navigate, we would go to KubeCon. We changed the persona we were hunting for. So instead of the goal of a conference thing being to get somebody to sign up for Fermyon Cloud, hoping they would, do that PLG thing and end up being customers, we really started saying, okay, well, we got to find, when you find a decision maker, let's scan that badge, let's do that. And so we kind of changed that motion quite a bit. And it was a kick in the ego for sure, because every developer wants to believe that product-led growth will work for them, right? That people will love your product so much that they will say, here, take my money, right? But at the same time, it was one of those challenges that really helped me appreciate, how big of an edifice it is that we have built as technologists, right? How complicated the stack is, and consequently, how to articulate value, right? How to say, in some ways, the PLG story never really tackled that problem we noticed at Microsoft, right? What was the problem? 80% idle, right? Developers don't really care about 80% idle. They care about how fast they can build their code. It wasn't until we had sort of iterated our way out of PLG that our eyes kind of snapped back open and we went, now we will be more efficient. Your systems are sitting 80% idle. Now we can get them to 10% idle, right? Mm-hmm. And suddenly the value prop that led us on this journey in the first place was the one we could put in front of customers. And that was very exciting, but ultimately not the end game. It turned out that was not the best strategy. Wow. Because it worked well for enterprises. But only if it hits a particular threshold. And so we found that really many small and medium-sized organizations didn't have the problem or didn't identify that as a problem simply because they didn't run enough compute. They didn't consume enough virtual machines. Their cloud footprint wasn't big enough for this to actually be a problem they needed to solve. So we had really good luck with very large organizations. But then, you're in the very long sales cycle thing, yep. and there was a lot of burden there. And then at a conference, at one particular conference in London, things took a third twist that caused us once more to sort of reconceptualize how we were reaching the market. So I was in KubeCon, or I was in London for Civo Navigate. Civo's a cloud provider, focused on small and medium organizations. Mm-hmm. And I was there because, I was trying to understand well how to articulate our value prop to that particular group of people. Civo's been a fantastic organization to work with. But I ran into an engineer from Akamai. So for those of you who aren't familiar with Akamai, right? Akamai is like the OG CDN. Like 1990s, they built the first CDN. The story is fascinating because the one of the founders of Akamai, Tom Layton, was actually an academic at MIT who sat a couple doors down from Tim Berners-Lee, the guy who invented the internet, invented the web. And the two of them would have these chats about where is this thing going and what are the problems we're going to hit. And they he ended up inventing the content delivery networks and this idea that you could push content closer and closer to the end user in order to cut down the latency that they would experience when they were loading a web page. And I mean, again, we're talking like dial-up modem period of time. And he was already thinking about these problems and started a company with some other guys called Akamai. Akamai built this network. Akamai also ended up sort of getting into DDoS defense because once they had spread out this network, they also could protect people against denial of service attacks. And really, they opened a brand new market that had never been there before. So they've been in that space very happily, serving many customers for decades now, right? But they were dealing with some pressure from a couple of new competitors, Fastly, Cloudflare, these companies that had started later as CDN companies, but were starting to see compute at the edge as a way to make substantial amounts of revenue, right? So Cloudflare is a good example of this. Yeah. Cloudflare workers basically run your JavaScript code at the edge. Right. You can get your JavaScript code, 2 or 3 network hops away from your end user. You can execute things very fast. You can do all kinds of interesting things at the edge. And Akamai was sort of looking at this and saying, yeah, we don't want to catch up or meet Cloudflare where they're at. We want to leapfrog Cloudflare. We want to figure out what the next generation of serverless functions are and get those out on the edge and kind of open people's eyes to yet a new set of possibility. They were calling edge native computing, where really you could offload so much of your work to the edge that you didn't need a data center anymore. And it was a pretty big vision for them. And they're, I'm talking to a couple people there and they're articulating this and I'm like, wait, but I got an idea, guys. I got an idea. I think we built the thing that you want, And so we ended up doing this partnership with them where Fermyon's serverless engine is powering the part of Akamai's, it's called Fermyon WASM functions inside of the Akamai ecosystem. And we partnered with them and we built that. And what we discovered, because we're talking about the audiences that we've gone through, right? First audience was very much developers. Yep. Second audience was very much platform engineers. And now with this thing deployed in Akamai, we can say, we'll host this and manage this for you, Akamai. And then you can expose this to your developers and they'll be able to build these kind of edge native functions. And so once more, we're kind of back into our sweet spot of primarily working with developers to articulate the value to them. But Akamai is taking advantage of, the improvements in latency and the improvements in density and things like that. So that has been a really fun partnership. And we're still definitely selling into enterprises. We've discovered more recently that a lot of European small cloud, privacy sensitive cloud, that kind of thing, a lot of those organizations are gaining traction and they want serverless environments as well. So we've talked to many of those about and are now starting to roll out Fermyon WASM functions inside of some of those organizations. But it's been quite a trip. And, everybody told me at the beginning, the hardest part of a startup is going to be figuring out how to sell your product. And I'm like, no, that's not true. Everybody's going to want my product. No, that was actually the hardest problem and kind of continues to be.
It's creating the noise, isn't it? I mean, like you say, you've got the developers. So there's probably a lot of people that know of you, right? So they might have used it at the beginning. So actually, you say Fermyon, they're like, oh, I remember those guys. And you've got the different products and what have you. And then obviously you've gone up the stack to obviously the platform engineers. You've now got obviously a massive partnership, with Akamai where obviously they're using your product, they're doing the selling. So again, that sort of works. I mean, how, I suppose, what's sort of the next steps for you then? So if you think about where you are today, getting out there, building those partnerships, do you see the success of obviously this partnership being replicated elsewhere, or is it more directly to the end client?
Yeah, so I think there's 2 ways to answer that. There's the technology way and the business way. I'll start with the technology way and hopefully get that to segue into the, the current vision for us has very much been this idea that, with being able to deploy to something like Akamai's edge, and Akamai is, continually expanding closer and closer to the end user, and being able to deploy into any Kubernetes cluster out there, and into, one thing I've been remiss in talking about is that for a long time we've had really good relationships with both SUSE and Microsoft, both of whom make it really easy to run Fermyon for spin applications inside of their Kubernetes or their respective Kubernetes offerings. We're finding this, we're starting to articulate this value prop of what we call the continuum of computing, where it's very much the case that you can have one application and you can deploy it to one endpoint, and that endpoint will say, this is latency sensitive. Let's get this part pushed as close to the end user as possible. This part really needs to be close to GPUs to do some AI inferencing. Yep. Let's keep this in the data center. And suddenly the developer is not thinking about or having to approach the problem as how is this going to get deployed? The system knows how to do that. And the system can kind of deploy the application according to the needs of the business, right? And that very much sort of changes the way we've had to build applications, where we've had to be, where I as a developer have to know what the environment is and build my code accordingly. So we're excited about that as a future direction. Now, if that's a future direction, right, if that's where we can go technologically, then what kinds of relationships does Fermyon need to build in order to realize that kind of vision? And that's why it has been so important to us to work with, Microsoft and Google and SUSE and organizations like that to make sure that we're understanding how people are using cloud, what they want out of cloud, where the value props align for cloud, and work with companies like Akamai who are doing the edge computing, and yet still try and keep track of those end developer experiences and say, as a developer, you can still go from blinking cursor to deployed application in 2 minutes or less. But this time, we're deploying around the globe within 2 minutes and not just to one, Kubernetes cluster. So I think that's the direction that we're headed as an organization. The AI stuff originally kind of was scary for us. I think I'm what you would call an AI moderate. I don't think AI is scary. I don't think AI is going to solve all our problems. It's awfully exciting though.
It is.
As a compute company, when at the end of the day for us, what we care about is how to do cloud compute more efficiently. We had this moment where we're like, oh, AI, big, scary, I don't know what we're going to do about this. And then we went, wait a minute. There's an awful lot of compute that AI has to do, right? They're using GPUs instead of CPUs in a lot of these cases, but it's an awful lot of compute. And so when we kind of looked at how this serverless environment would work with it, we started stumbling sort of in the general direction of agents, and then other people defined agents, and we went, yeah, that's what we were thinking of, and so I think that, one of the ways that will accelerate us getting from where we are today and to getting where we want to be in the future is being able to articulate some of this compute continuum using agentic AI as an example of this, and as one of the kind of core workloads, along with, the original vision was very much aligned around capturing the same kind of developers that were building AWS Lambda functions. And then, as, Cloudflare workers. But now we're going, well, there's this giant greenfield space of people who are building agents. That's another group that is looking for a platform that's going to be easy to use, where they don't have to know a whole lot of the hardware, where they can write a function and have it do things and then just deploy it and not worry about it anymore. So that's opened a lot of possibilities for us, and I'm very excited about where that is today and where that's going.
Absolutely. I mean, I think, between now and 2030, I think inferencing is probably one of the biggest sort of the growth markets. And then behind that it is agentic AI. And they're the two that, as a business that we're looking at, right? Because obviously the growth opportunity, the investment going into those, and the new startups that probably need the help of a Fermyon, that they're there, right? And that's the thing. So it is an exciting market. I mean, going back to running the business, you're the CEO. Huge career as an engineer. Obviously, there's loads of startups that are founded by CEOs that are engineers by trade. How do you turn your engineer head into I'm running the business head? And to your point, you said it about 10 minutes ago. Your biggest thing is, how do I pay the wages? Your number one job really is to pay the bills. As the CEO. Yeah, that's right. And that's a lot of stress and a lot of pressure. Right? I have it here. How do you flip to, crikey, I love building this product. Your passion for it is playing for everyone to see that's watching this. How do you go to do the business side of things as well? Yeah,
and that is hard, right? It is essentially learning an entirely different. It's not a different. it would be convenient to say it's learning a different skill set, right? But that is not at all what it is. It's learning a different mindset about how to do things, right? It's learning to take a very different perspective. Engineering is nice because you say, okay, I've got this system. It's going to abide by rules. All I have to do is write the rules, and if I write the rules correctly, it's successful. I've filled the brief, right? I met the brief. Leading a team is very much different than that, right? Because you have no ability to control the rules of the game, right? The PLG story I told at the beginning is a good example of this. The market shifted, not a thing I could do about it. AI caught on, market shifted, not a thing I could do about it. So there were a couple of things that have been lessons for me personally that have helped me adapt. The first one has been that you accept what the environment gives you. And you just have to react in some cases, right? I cannot force my plan to execute well. But if I can get out there and articulate according to the input what value that we're adding, that was a big thing. So a lot of it was just learning to be a marketing person and say, I hear what you're saying. Let me try and articulate back to you why I think we're valuable to you. Instead of saying, but here was the brief and here's how we filled it. It's, take the input, churn on it and kick it back. That helped with a lot of the marketing function. With the business function, I got to say, there's no way I could, read my way into an MBA in a couple of years or something like that. So one of the things I'm most thankful for is, one of our earliest hires was a guy named Tim Enwall, who is a multi-time founder, had been, done successful acquisitions, launched successful long-term companies. He was a mentor of mine. And at some point he said, this is a really cool business idea. I kind of want to be part of the company. And I said, really? and so he hired on as the COO and, really put that function into place. And that was within the first, he was mentoring us at the beginning of the company. Probably within 6 months, he joined the company. And so my lesson from that, if it hadn't been for him offering, I think I would have believed that my responsibility as the CEO was to learn everything on my own. Yeah. And that until I had achieved mastery on my own, I couldn't hire somebody to help. In hindsight, if he hadn't stepped in and said, I can help, let me teach you how to do this, let me take over, I'll do the bookkeeping, here's how you want to set up HR, those kinds of things, I would have drowned within the first year. And so having him around I think was one of the key enablers for Fermyon to start to achieve the success we're achieving now.
That's huge, isn't it? Bringing people in to take on certain responsibilities so you can do what you're good at, and bringing in people that are better at other things. You can't be an island in a business. You'd just drown, like you say.
Exactly. And part of it is putting aside ego, right? Because we all want to be, as a CEO, I should be, and there's an ego thing there. And part of it is also the opposite, right? Is saying, I know I'm not good at this, right? Why am I trying to force myself to be a person I'm not? Why am I trying to pretend that I have the mind of an accountant or the mind of an HR expert when there are HR experts and accountants that I can hire? And I think I would have originally felt guilty about it, oddly enough, because in a way I felt like I might be shirking responsibility, right? I'm supposed to be the CEO. I'm supposed to know everything. But man, just having somebody bootstrap that and that person then, saying to me, no, the key is to find people who are experts in these fields. And your only job right now is to fill in until you can hire somebody that's going to do a better job than you. And so start looking for those people. That changed my way of viewing it. At first, I thought I had to be an expert in all things. And now, I understand that team building is about finding the right experts and merely being able to sort of coordinate a lot of that work and get, proficient but not expert in all of these different things.
It's a huge thing, isn't it, really? So, and just thinking of the future then, so we talked a little bit about, obviously, agentic AI being something. Where do you see, yourselves adapting? Because part of your history is sort of pivoting, recognizing the direction you were going in. It was working but wasn't working. So we'll take a left, then we'll take a right, and you've made your way through over the last sort of 4 years. What do you think the next 2 years is sort of focused on? Do you think you've got that much sort of foresight, or do you think it's just sort of roll with the punches and see where the industry's going?
I think there's a piece of the original puzzle that we first uncovered that we are still working on solving, and that I think is going to be the expensive part for the next 2 years, right? Along with being really interested in running high performance workloads in the cloud and kind of figuring out this third type of cloud compute. The other big area that used to be considered purely academic that I think needs to turn into every developer's everyday responsibility is true distributed computing. And it really has kind of made some inroads, right? When I was writing those CMS systems back in the earlier days of my career, we wrote monolithic systems. We wrote gigantic multi-gig bodies of code that ran in one very, very large instance. As Kubernetes came around and the microservice development pattern came around, we started breaking our applications into smaller chunks. But then the advantage of that was, as a developer, I only have to manage a microservice's worth of code instead of a monolith's worth of code. But the disadvantage of that is then I, as a developer, have to know how to wire up all of these systems, and I have to maintain them. And, table stakes problems like locking become the bane of my existence all the time. And it's very hard. It's low level code that's very hard, but also somewhat repetitive. One of the things that one of WebAssembly's kind of secret superpowers is this thing called the component model, and it effectively makes it possible to compile chunks of your application into separate WebAssembly binaries, and then have the runtime be able to connect those binaries up and wire them together. So essentially, it's like the WebAssembly system itself knows how to build microservices. Yeah. And I think that we're going to be able to take advantage of that to achieve this kind of next wave where we'll be able to say, when I as a developer write an application, I write it like this, and I break it into little units of work. Those get compiled into separate components. When I deploy it, the system says this component should go here. This system should go on the other side of the world over here. This one goes in the data center. This one goes on the edge. And that's how we'll kind of get to that edge native story that I told before. It's a big technical lift, right? In order to build that system and make sure it works well, requires a lot of very, very smart engineers doing very low-level engineering. And so part of our team is sort of dedicated towards solving that problem. And some of that benefit accrues to us right away because, as we go, we're making it faster, we're doing better at multi-tenancy and things like that. But part of it isn't really going to accrue until all those core technologies line up and the component model is done and we can deploy those out. It pairs really well with sort of the agentic AI version of the future. Pairs really well with, the sort of emerging trend toward deploying into multiple regions all at once. So there are a lot of trends that are emerging right now that I think this will just sort of fit right into. But it's a heavy engineering lift. The nice thing is, no, I shouldn't say this. I was totally going to say the nice thing is I think it'll be easy to sell, but that's exactly the problem I make all along. I do think this kind of vision of building complex applications, testing them locally, deploying them, and having them distribute automatically is going to be very appealing, but it probably will take some time to articulate how that works and why it's a safe and productive thing for people to do. But it's something I'm really excited about. I think it's sort of the next wave of infrastructure engineering.
That sales engine and banging the drum is the challenge that every business has, right? So you create a great product, you create a great service, and then it's like you say, it's the partners, it's having a great commercial team that can go out there and find the route to markets. That GTM strategy is one that's going to be pickling people's brains for quite some time.
And I keep thinking it's going to be easy, and it never gets any easier, right?
If it was easy,
you find product market fit. You find product market fit, and that's a great feeling, right? Like the day we went, we now know who the market is for our particular product. That's a great feeling, but it always does seem that there's always a challenge in taking a new concept, articulating it clearly, and articulating it in a way that people say, I would be in to try that. Let me see if it really does give me the value you say it's going to give me.
You've been really forthcoming and open about some of the challenges that you faced as a startup, which is great, because actually we all have them. For somebody that is, in a similar position, maybe a few years behind where you guys are, a very early stage startup or about to take the leap into that journey, what sort of advice would you give those people that are looking to take on that next challenge and set up their own business?
I think the most important thing for us that we learned early was your first few hires are going to shape the entire culture of the company. The first few times you articulate internally what your company culture are, those are going to have sort of an outsized, amplified effect. There's some key moments in that first year as a company that I can think of. The first time I tried to write what the company values were going to be, right? The first time we had to make a decision between respecting the engineering team we had and their need to, take a break and get a rest and stuff like that, versus trying to get something done according to a timeline. There are these key moments there where you find you have to make some decisions that are going to shape the culture that you're going to have long term. Am I going to be the kind of CEO who makes deadlines so rigid and so inflexible that when somebody has a family emergency, everybody else is, on fire for the next, things like that. And I would boil them down and say just this, because everybody's going to build the culture that you want to build, right? And I love our culture. I think we did a great job on it, but it's our culture. It's not everybody's culture, right? So I think the thing I didn't realize at the time that I hope everybody realizes as they get starting their own companies is that those first few decisions are actually very crucial, right? That first year, every time you're making those culture decisions, you're laying down not a path, a road, right? It's going to be really hard to reorient later once you have sort of created that initial culture. So the tendency to get into, if you start out as a move fast and break things kind of company, 5 years down the road, you're going to say, are we still breaking things? Because we've been moving fast. Those simple things you say at the beginning become sort of enduring, very difficult to change things. So be extra intentional about those early on. And as a corollary there, those first few hires are absolutely critical too, as far as not just finding the right problem, finding the people who solve the right problems, but finding the people who are good to work with. Right, who are going to be part of that culture and who are going to be a productive part of that culture. So there's a lot of, and why is culture building actually? This is a good one too that I learned. Why is culture building important? You can read.
Might help you with that.
Right? Yeah, this is where the philosophy comes out. Right? You go and read like Harvard Business Review or something like that, or a bunch of Inc. magazine articles, and you're like, oh, culture is important because we want to be all happy and feel good, right? Well, yeah, I guess sort of. Like, it's really important to me that my job has meaning. That's definitely true. But why, right? Why is that in service of the company? Well, we want to pay everybody's paychecks, right? That's the goal of the company. Produce something that brings in enough income to pay for, and if we want to get there, then what we need is the highest performance out of our team that we can get. Well, how do you get high performance out of a team? Well, when everybody feels like they're flourishing and working in an environment that they'd like and have a problem that they understand and are excited to come to work in the morning, then they're going to get more done and they're going to do a better job at it. And so, when I kind of thought about it that way, again, philosophy degree coming out, it was like, oh, well, culture is really important because I want to build the kind of environment that incentivizes all of us to hop out of bed in the morning and log on and be good to each other and be highly productive, right? So once I connected that, it helped me go from reading a random HBR article and going, oh, it's important to me that we have high EQ people, to going, oh, no, right. It's important because it's going to help us get this job done better. And that is going to be the kind of snowballing effect where if we do well on it today, we'll produce something that's good, which will mean it'll be easier for us to do well on it tomorrow and so on, right? And so it's a self-reinforcing cycle when you build a culture that ends up creating flourishing with your employees and yourself, right?
I think that's it. I mean, at the end of the day, no one's going to care and want this to be a success as much as the founder. So you have to find a way to get them passionate, excited, motivated, feeling rewarded, like I say, pay the bills, but feeling successful. People that feel good in their jobs tend to be far more productive. So I totally get it, and I can see why you recognise that right at the beginning, and that was really important to you. So look, in summary, just from your 4 years, nearly 5 years, you guys have been pivoting your strategy. It's about hiring the right sort of talent. It's about building the right sort of culture, and then finding your strategy around getting the word out there and the go-to-market strategy. They're all the sort of challenges that you guys have been facing, and just adapting the product. You guys are engineers, you know what you're doing. So it's getting that and taking it to market. Look, it's a really exciting business, and I think we talked about it on our meeting previously. There's obviously a huge demand for something like this for some of the neo clouds that we deal with, but again, obviously there's an opportunity there with the agentic AI and within inferencing. There's so much that this can work. So I'm excited to see what happens with you guys over the next sort of 12 months, and want to get you involved in the humans and AI community as well, because I think there's people that need to know more about you guys. The fact that Microsoft and SUSE and Akamai are all bought into it clearly shows it's an exciting business to be part of.
Well, thank you very much, and it has been a pleasure to talk with you. I knew from we did the meeting a couple of weeks ago that this was going to be a fun one, but the trends in neocloud, trends in AI, things like that are setting us up, I think, once again to have a good solid iteration in the way that we do these kinds of cloud technologies, and I think the future is very bright right now on the technology side, and I'm really excited for the kinds of things we're going to be building over the next 2, 3, 5 years.
Absolutely. And I think, look, for anyone listening, anyone that's interested in, learning more about you guys, you're happy for people to reach out to you on LinkedIn and ask any questions?
Yeah, absolutely. LinkedIn's the best place to find me too.
It was how we found you.
Yep, right.
so point in case. But look,
never would have thought that would be my preferred social media, but at this point, I like LinkedIn a lot.
You and me both. But look, this has been brilliant. We'll have you on again. Keen to keep following the journey. But thank you very much for your time today. It's been great.
Yeah, very much appreciated. Thanks a lot.
No worries. You take care now.
Thank you for listening to today's episode. I truly hope you got to take away something valuable. This episode was brought to you by Asobi. I'm the founder and managing director, and it's our goal to connect the very best talent with the most exciting scale-ups in AI, ML, and the DC space. If you're looking for more practical advice or just some inspiration from those that have been there and done it, stay with us. We're going to be releasing new episodes every week, so make sure you subscribe to the podcast and follow Asobi on LinkedIn so you don't miss a thing.